This is Research Like a Pro, episode 245, RLP with DNA 8, Part 1, DNA Tools and Methodology, Genetic Networks. Welcome to Research Like a Pro, a genealogy podcast about taking your research to the next level, hosted by Nicole Dyer and Diana Elder, accredited genealogist professional. Diana and Nicole are the mother-daughter team at FamilyLocket.com and the authors of Research Like a Pro, a genealogist guide. With Robin Worthland, they also co-authored the companion volume, Research Like a Pro with DNA. Join Diana and Nicole as they discuss how to stay organized, make progress in their research, and solve difficult cases. Let's go! Today's episode is sponsored by newspapers.com. Break down genealogy brick walls with a subscription to the largest online newspaper archive. Hi everyone, welcome to Research Like a Pro.
Hi, Nicole. How are you today?
Great. I'm excited to start working on my study group project again after Roots Tech being over and be able to work on the John Robert Dyer father case again, which takes me back to the very first DNA study group we did when I worked on that.
Oh, that's so great. It's so fun to get back to your own research, isn't it?
What about you?
I'm doing the same thing, getting back to my study group project, which is using DNA to confirm John Cary Royston as the father of Thomas Beverly Royston. So this was my third generation for my 4-generation project for accreditation, and I have a very extensive research log from that from several years ago. So I'm now going to import that into Airtable so that I can add the DNA evidence, and I'm excited to get back to that research as well. You know, it's just so fun to return to a research project, and I feel like the documentary evidence is so strong, and all I had used before was Y DNA, but now I really want to confirm it with the autosomal DNA, which should be really interesting.
That should be. So you already have Y DNA evidence for this generation, right?
Right, for the entire Royston line back to the immigrant ancestor, Thomas Royston, who came to the United States in 1621. Yeah, our Royston project involves several different descendant lines of Thomas Royston, and my descendancy line that came all the way to California matched others that stayed in Virginia and went different places.
So you're proving which generation and with autosomal DNA?
Well, for my accreditation project, it was the third to the fourth generation. So from me, it is actually my third great-grandfather to my fourth great-grandfather.
And that's Thomas Beverly to John Cary?
Right.
So do you have a test taker from John Cary that branches from a different line with the Y-DNA than your Thomas B. Royston's line?
I do not have a test taker. I have DNA matches. He had several wives, so this would be from his first wife. So that's what I'm going to be exploring, probably half relationships, unless I can determine some matches that came down from Thomas Beverly's sister, who married an Irwin. So I'll be looking for some Irwin matches to see if there are any descendants coming down from her, and then looking for some matches from half-siblings as well. Ooh. That were coming from John Cary Royston's other wives. He had a son, Richard Royston, and actually the town of Royston, Georgia is named after this Richard Royston, and I believe there's a lot of descendants that came through his line. So I will be exploring that.
That'll be great. Those half relationships can be so challenging back in time. There's not a lot of data from the Shared San Morgan Project for like anything beyond half-worth cousins.
Well, luckily I have a test taker who's 2 generations closer to Thomas Beverly Royston than me. And so I'm actually using his results. He's one of those long generational lines. And so that helps because it's his great-grandparents instead of like third great-grandparents, as it is for me. So that will be helpful.
Well, great. That's just such an interesting project, and I'm excited to see what you discover with it.
Me too. I just have to get to work on it.
That's always the case with our projects, right? We always want to know, and we have to dedicate the time and the work to organizing all of our data.
Right.
Speaking of organizing our data, we announced in our last week's podcast that we have our new Airtable Quick Reference available, which is a 4-page PDF that you can download from our website. It's available for purchase now at an introductory price. So get that before it goes up. And also we have our Research Like a Pro webinar series that features monthly case studies from us and our researchers. And if you would like to join our study group, the next one is this fall, Research Like a Pro study group. beginning in August. To be a peer group leader during our study groups, you can apply at our website and you receive complimentary registration. And your main job is to meet weekly with your small group of peers and facilitate those meetings and also give feedback on their assignments as we go through the study group. To learn more about different things that we have posted or new podcast episodes and receive coupon codes, make sure you join our newsletter that comes out weekly on Monday. And as far as conference news, Roots Tech is over, but the videos from the presenters who created recordings of their lectures and those that were live streamed are available to watch on Roots Tech's website. And the National Genealogical Society Conference is open for registration and has many wonderful talks, including several by my mom, Diana. Yay. So that's exciting. And we are just highlighting that the Association for Professional Genealogists, or APG, is having their professional management conference this year, and they have a call for presentations open. The conference is October 19th through 21st in person or virtually on Whova, and it has some great lectures usually about business practices and ideas to benefit your career. So I know we have a lot of listeners who are genealogical researchers and professionals or considering going that way. So this is a great conference. And they're just looking for all kinds of presentations that have to do with your genealogy career.
Right, that's a great conference. I went to that in Kansas City years ago and presented on accreditation with my colleague. And it was so fun to talk to other professional genealogists and just get different ideas. So I'd highly recommend that for anyone interested. Well, today's episode is all about Chapter 8 from our book, Research Like a Pro with DNA. And this chapter is titled DNA Tools and Methodology. And because this is a long chapter and it has a lot of great tools, we are dividing it into 2 episodes. So today we'll be talking about using pedigree triangulation. And then next episode we'll talk about tools for segment analysis. So let's think about our documentary research. We use a lot of different methodologies, a lot of different record types, and just like that, in our DNA work, we also use different tools and strategies to help us in this process of working with our DNA and helping to visualize the information needed to make connections. So in the book, we have a bell curve, which was created by our colleague and fellow author Robin Worthland. And the bell curve is how we've organized this whole idea of tools. And it illustrates a methodology for working with DNA in our family history research. And so if you can picture a bell curve, small on the left, larger in the middle, and small again on the right, the far left are the simplest tools, and then the most complex DNA research tools on the right. And the highest point suggests where you'll likely spend the bulk of your time. The left half of the graphic shows tools not using segment data, and the right half depicts those using segment data. Just note some projects may not require the more advanced tools, but others may benefit from their use. Just like in any research project, sometimes you need to use land or court records, and other times you don't. So it really depends on the project. And the graphic, the bell curve, can help you determine which tools to choose depending upon your research objective. And remember that genetic genealogy is continually maturing, and so that is why we do new blog posts on our website, Family Lock, and why we do new podcast episodes to keep you up to date on the latest and greatest with the tools. So let's start with the far left of the DNA Tools bell curve, which is ethnicity estimates, which I believe Nicole is going to walk us through.
So ethnicity estimates is something we covered in the last episode, so we won't talk about it too much, but it is a tool that we can use to help us sometimes separate the DNA matches. And reviewing the ethnicity estimates at the beginning of a research project can provide important clues for the analysis in some of our projects. And as we discussed, every major DNA company offers a view of your admixture or ethnicity composition. So I just want to refer you back to that previous episode about Chapter 7 that discusses all the details and applications of using ethnicity estimates. But it is a very good thing to make sure that we're checking at the beginning of a project, especially a project where we can group or separate matches into clusters based on whether or not they have a specific shared ethnicity with our test taker.
Right. So let's talk about this idea of finding the most recent common ancestor, or the MRCA. And this is the purpose of using DNA tools. We are trying to find the common ancestor between us and our DNA match. And so both a DNA test taker and a DNA match inherited at least one and perhaps more pieces of DNA from a common ancestor. And so we can think of a visualization of a triangle, and we have a common ancestor at the top of the triangle, and then the legs coming down to the test taker, and then the other leg coming down to the DNA match. And so we have got a relationship between our test taker and our DNA match, which could be something like third cousins, first cousins, second cousins, fourth cousins once removed. We have so many different relationships. But regardless of the specific relationship, the lines for the test taker and the DNA match go back to a common ancestor or a common ancestral couple. And so that is our whole idea of DNA work, is trying to find that common MRCA.
So, the next part of this chapter is all about creating genetic networks. And this concept of finding the most recent common ancestor between two matches is key in understanding the use of these genetic networks tools. So, in the DNA tools bell curve, we do suggest using genetic networks tools early in your process. We use these tools first because they separate DNA matches into groups based on their relationships to each other. And that grouping makes it easier to determine the common ancestors for a group of shared matches. The cluster groups may include descendants of grandparents, great grandparents, and so on. And so we do have to do some detective work to figure out the most recent common ancestors for each cluster. And a cluster may be composed of matches who have different common ancestors with the tester, but usually along the same line. So some may descend from the tester's great grandparents, while other matches might descend from the great grandparents' parents or grandparents. And in other cases, the common ancestors may not be the same for all cluster members. Some may be descended from a particular ancestral couple, and others may be descended from collateral relatives of that couple. So, to start, you will separate your matches into groups related to maternal versus paternal sides. Next, you can subdivide those groups into 4 groups related to your maternal grandmother, maternal grandfather, and paternal grandmother and paternal grandfather. Then you can continue to subdivide the groups into people related to great grandparents, second great grandparents, and so forth. And it isn't always as cut and dry as separating each group into then 2 more groups. And sometimes the groups are combined and are overlapping. And we just have to do our best to try to figure out what line that group is from and see if that helps us narrow down to the relevant group of matches that are relevant to our research objective.
Right. So we have a lot of different methods that we can do for this. And DNA testing companies each give us shared match tools or reports. And these reports identify DNA matches who share DNA with you and another match in your list. And you can use these tools or reports to create genetic networks manually. So here are the different names for the testing companies. They each have a little bit different name for how to find these shared matches. 23andMe titles it Relatives in Common. Ancestry DNA titles it Shared Matches. Family Tree DNA uses In Common With, or ICW. MyHeritage uses Shared DNA Matches. Living DNA uses Relatives. And GenMatch uses the term people who match both kits or one of 2 kits. So it'd be nice if they all had the same name, such as shared matches, but they don't. So you just have to recognize that and learn how to find that in each of the autosomal DNA testing companies. So once you have figured out what they're using for shared matches, You can use the shared matches report from any company and create a color cluster chart that separates matches into 4 grandparent groups with the Leeds method, which is a wonderful method developed by Dana Leeds, where you use a spreadsheet and separate out your matches into your different groups.
Great. And we can just follow the tutorial that Dana Leeds has on her website. One tip that we like to share when using the Leeds method is to focus on confirmed second cousin matches when you're selecting the starting person for each shared match cluster, because if you accidentally choose somebody who's actually a child of your cousin, they're actually a first cousin once removed, then the common ancestor is your grandparents, then it won't help you separate it out into the 4 grandparent groups, because they will create a group that's actually descended from both grandparents. So it's important to kind of be thoughtful as you're choosing the starting person in your Leeds method cluster groups. So we recommend starting with the Leeds method because once you understand that manual method of separating into clusters, then it's easier to understand how the automated methods work. Let's go into these automated methods, which were created after Dana Leeds came out with her method, and they were based upon her method. One of those methods is the AutoClusters, which is heavily dependent on the same idea of the Leeds method. So the AutoCluster programs are one way to automatically separate into groups. And then another way, which we'll talk about, is network graphs. And both of these tools make use of techniques from a variety of disciplines to simplify and streamline genetic network analysis. What's great about them is that they're efficient in putting the clusters into groups for you. But we really think it's important that before you jump to these, that you've at least tried the Leeds method on your own so that you can see how it works.
Right, and a lot of people like to use the color dot system as well to separate into genetic networks and doing that manually. And so Ancestry and MyHeritage both have the color dots that allow you to do that, to separate out your matches by shared ancestors. So let's just go over the AutoCluster programs that are available and how to work with those. So an automated AutoCluster program will display your DNA connections in a matrix, and this can also be called a design structure matrix. It's a widely used technique for comparing engineering and project management information. So there are a number of third-party tools that offer these colorful matrix cluster reports just at the click of a button. Genetic Affairs, you may have used or heard of, and that works with 23andMe and Family Tree DNA. And then MyHeritage AutoClusters, which also work licensed through Genetic Affairs. We have GEDmatch Tier 1, the Colin Leeds method at dnagedcom.com, DNA to Tree for iPhone and iPad, and Shared Clustering by Jonathan Brecher. So you can see we have a variety of third-party tools that do this clustering for us. So let's start with Genetic Affairs. Everett Jan Blom, the creator of Genetic Affairs, was one of the first to analyze DNA using AutoClusters, and it uses a computer algorithm that compares you to your DNA matches and then your matches to each other. And as I mentioned, you can use this AutoCluster analysis at Genetic Affairs for 23andMe and Family Tree DNA. And then MyHeritage and GEDmatch licensed the Genetic Affairs AutoCluster analysis for use directly from their websites. Now, the Collins Lead method is built on the methods developed by Dana Leeds that we were just talking about, the Leeds method. And so that does the work automatically for you. You do go through the DNA GEDCOM website, and you use the DNA GEDCOM client to gather match data from Family Tree DNA, 23andMe, MyHeritage, and Ancestry DNA, and then the Collins Leeds method will separate the DNA matches into clusters for you. Now, the DNA to Tree app is iOS-based, and it's a subscription app. So you have to have an iPad or an iPhone to use it, and you load your Ancestry DNA matches into the program, find common ancestors, you can calculate DNA clusters, and even build a birth family tree at Ancestry.com. So let's just try to visualize what this matrix cluster report looks like. So if you have ever done this, you will know that you have got colored clusters, and they show up as a matrix, so they show up as big squares, a lot of little squares making up a lot of big squares. And you will find that you also may have some gray squares intermixed in between the large colored squares. So in a cluster report, the DNA match names are listed both along the top and the left side of the chart. And generally your DNA matches are grouped with others that share a connection to a common ancestral line, and the colors distinguish the clusters. You don't get to choose your colors. That is automatically done for you by the program. And the arrangement on the chart will suggest how the clusters connect. So how do you discover the common ancestor of each cluster? Well, you have to look at family trees to see what might be the common ancestor of all these different people in a cluster. We have seen some reports that are just one huge cluster where everyone is related to everyone else. And so if you see something like that, that will give you a clue that you are maybe dealing with endogamy or severe pedigree collapse. So when these matrices are created, you will see that a DNA match can only be in one cluster at a time because that is how the computer algorithm works. Because they might also appear or need to be with another cluster, they will have a gray square outside of the main cluster showing another connection. This could be just the result of being included in another more distant generational cluster. So someone could be in a grandparent cluster, but then they also appear in a great-grandparent cluster or a great-great-grandparent cluster. As you are looking at it, just keep in mind that you will have to do some work in understanding what this cluster chart is telling you. So E.J. Blum explained how a DNA match is assigned to a cluster, and he writes, "The number of links with a cluster is used as the deciding factor in cases where a relative could be a member of two clusters. For example, if DNA match A has 10 links to cluster 5 and 12 links to cluster 6, it will become a member of cluster 6. If there are new matches available that result in more links to cluster 5, it will switch cluster membership." So just know you might have a DNA match that appears in more than one cluster, and the algorithm has its own way of figuring out where to put that specific DNA match.
That was such a great explanation of the automated AutoCluster tools that we can use to help us expedite the grouping of our matches into clusters. Another tool that I love is the network graphs tool, and the concept of network graphs is wonderful. There are actually several tools you can use to build one, but they are a little bit different looking than the matrices. They are connected groups of related people who form circular clusters, and the clusters of matches show that they are shared matches within that cluster. And there are also lines connecting matches to each other and lines connecting each cluster to other clusters. So they can show you how the clusters could be related to that MRCA couple of that one cluster going back further on the line. So it gives you clues to which cluster to analyze next. 3 of the tools that you can use to create network graphs include Roots Finder, Node Excel, and Gephi, which is spelled Gephi. Starting with Roots Finder, this is a user-friendly tool designed specifically for genealogy. It helps you create a family tree, and it also allows you to upload your DNA match information and shared matches if you download that first with DNA GEDCOM. You can also import triangulation data from GEDmatch to visualize relationship clusters based on segment data. Gephi and NodeXL are not designed for genetic genealogists. They are designed for network analysis for other business professional type things. However, if you can invest the time to learn the programs, then you can manipulate the results in many ways, and you can make your own network graphs that are very flexible to your needs. Shelley Crawford wrote a series of blog posts at Twigs of Yore about how to use NodeXL to create network graphs. That's a valuable resource. After we wrote this book, I came out with a series about how to use Gephi to create your network graphs. You can see that on our website, and we'll put a link in the show notes, which I learned how to use Gephi from Shelley Crawford as well. So she really was a pioneer in creating network graphs, and I'm very grateful for her sharing her knowledge. So to understand a network graph, you need to know that a node in the graph represents your DNA match, and the lines connecting the matches to each other indicate that they are shared matches. And when a group of matches has many connections to each other, they form a cluster. And each DNA match in a cluster of matches is likely related or connected along a shared ancestral line. And an individual in the graph might connect to several clusters. And this scenario could mean that they are a closer relative than other DNA matches. Those closer matches can help you identify which side the cluster is on. For example, your first cousin would connect to many clusters, those with descendants of your shared grandparents, great grandparents, and second great grandparents. Usually, we exclude really close DNA matches like your immediate family members because they would connect to like every cluster. So, that would be difficult to read the network graph if you have so many connections to some of your biggest, closest matches. Another challenge is that individuals who have pedigree collapse or endogamy will not have clear separations of clusters all the time. You will have some clusters, but depending on how severe the endogamy is and how many of your grandparents were from that endogamous group, you may not be able to see any clear clusters emerge at all. So it's important to recognize the limitations of this tool for those with pedigree collapse and especially with endogamy. In the book, we have an example of my network graph that I used with my John Robert Dyer case. And there was a cluster that I identified as descendants of John Robert Dyer and his wife, Bathsheba Tharp. And then there was another cluster very closely connected to that one that included a lot of descendants of a group from North Carolina who all seemed to descend from two sets of common ancestral couples, Moses Taylor and Elizabeth Pravat. Also, some people from the Doherty family who married the Taylor family. So there were just kind of these few ancestral couples that I kept seeing over and over, which gave us a hypothesis about John Robert Dyer's mother, who we had one source that was a family narrative that they thought maybe her name was Sarah Taylor. So that cluster of matches seemed to confirm that the identity of John Robert Dyer's mother was probably someone named Sarah Taylor. And she still hasn't been identified because there were several different Sarah Taylors at that time, and none seem to have any connection to our John Robert Dyer, who lived in Hawkins County, Tennessee. But further analysis of that network graph and that cluster who all came from that group with additional test takers and finding more matches could eventually help us tease that out.
And I remember when you were first working on that network graph and finding Sarah Taylor's name popping up. That was a fun discovery. Network graphs are like a huge puzzle to figure out what's going on in them. So fun. Well, now we have a word from our sponsor, newspapers.com. Did your ancestor disappear from vital records? Maybe they moved or got married. Newspapers.com can help you find them and tell their stories. Or have you had trouble figuring out how people tie into your family tree? Newspapers are filled with birth notices, marriage announcements, and obituaries. Items like these are a great resource for determining family relationships. On newspapers.com, you can explore more than 800 million newspaper pages from across the United States, United Kingdom, Canada, and beyond in just seconds. Their easy-to-use search feature lets you filter your results by date, location, a specific paper, and more. When you find something interesting, the newspapers.com clipping tool makes it a snap to share it with family and friends. You can even save it directly to your ancestry tree. For listeners of this podcast, newspapers.com is offering new subscribers 20% off a Publisher Extra subscription, so you can start exploring today. Just use the code FamilyLocket at checkout. Well, now we're going to talk about pedigree triangulation. And after we have grouped our DNA matches into these genetic networks, next we are seeking pedigree triangulation, which is a methodology that most genetic genealogy projects will utilize. This identifies the common ancestor among a group of shared DNA matches by comparison of family trees. So triangulation brings to mind a triangle, a shape with three sides. And in this case, it's actually a three-dimensional pyramid. And the base corners represent you and at least two of your DNA matches. And the top represents the shared ancestor from whom you each descend. So picture this triangle or maybe a pyramid with three bases. And you have a DNA match 1 and DNA match 2, and you all share DNA with each other. So we are trying to identify the MRCAs that we share with DNA matches. And we're looking for the common ancestors that are the closest generationally to us. So the 3 or more DNA matches considered in confirming a common ancestor should descend from independent lines. In other words, the DNA matches should descend from 3 different children of an ancestor. So there are some steps that we take to achieve pedigree triangulation that we will explore. Those are to estimate relationships between you and your DNA matches, comparing trees, and then building diagrams and trees.
So the first step is to estimate the relationship between you and the match. And if you can do this, you'll have a clue about how many generations back your shared ancestor will be. So each DNA company website gives you the amount of shared DNA, and they will either give it to you in centimorgans or in percentage. And then you can use the shared centimorgan project tool at DNA Painter to identify possible relationships that can then be analyzed and verified by looking at the trees. So some of the tools that you can use to analyze the amount of shared DNA are, first of all, the DNA match list at DNA company websites. So 23andMe DNA relatives, Ancestry DNA, DNA matches, just the list of matches at all the companies. And then at GEDmatch, it's the one-to-many DNA comparison. And then you'll use the shared centimorgan project tool at DNA Painter to identify possible relationships.
Those are the tools we use to analyze the amount of shared DNA. And then we need to compare family trees. This is so key to this step. And so we're going to talk about some tools for building and comparing family trees because we need to know how to do that. So we have to remember family trees as they are found online show the family going back in time, perhaps with an entire family group. But rarely will they show you the path between you and your DNA match. Instead, they show parts of the path that must be completed through your own analysis of matched family trees and correlation of those trees with documentary evidence. So if you can determine which ancestor you and your DNA matches share, you can verify that you're genetically related to that ancestor. Now, as you compare your family tree with those of your DNA matches, you can really only look at one family tree at a time, but you can consider the family trees of multiple DNA matches. And so you can open separate tabs on a computer screen, or you can print the horizontal pedigrees of DNA matches and look for shared or common ancestors. And when multiple DNA matches share a common ancestor, this is robust support that an ancestor is biologically related. One of the things that you can do is look for common surnames as you compare family trees attached to DNA profiles. Then you would want to explore the pedigree and localities to find the common ancestor shared by you and your DNA matches, or shared between genetic cousins in that same genetic cluster. There are a lot of tools for comparing family trees. First of all, if the DNA testing company has family trees, you would use those. And so those are found at Ancestry, Family Tree DNA, and MyHeritage. They all have trees that can be associated right on the website. But another thing that I like to do is use the Family Search family tree, which is a big collaborative tree and can be a really great tool for looking at descendants of an ancestor and trying to find the common pathway between you and your DNA match. WikiTree is another collaborative tree that can be used. And then there are trees on GeniaNet, Genie.com, Philae.com, Find My Past, GEDmatch, and DNA GEDCOM GWorks. So those are all some different tools that you can use for comparing your family trees. At the DNA test company, the trees are associated with the DNA match profile. Unfortunately, many of our DNA matches do not have a tree associated, and so we have to contact them and try to find more information about their family, and we may need to build the tree for them. But these collaborative family trees, such as Family Search and the WikiTree, can be very, very helpful in trying to figure out a family. So some of the tools are available at DNA GEDCOM, and they help you search online family trees attached to your DNA match and help you identify common ancestors. And one of my favorites is the one through DNA GEDCOM called GWorks, and it compares GEDCOM files consisting of family pedigrees for separate matches, and it lets you identify common surnames that helps you search for your ancestors. So if that sounds like something interesting to you, you can explore DNA GEDCOM and GWorks.
GWorks is great because you can sort by different things. You can sort by birth location, last name, you can filter. It really has a lot of tools to help you with different hypotheses. Like if you have a certain surname that you think you're going to find in your DNA matches, you can filter everybody with that surname and see if they are in that correct cluster that you're hypothesizing about. So it's pretty great. Next, let's talk about building trees. So, creating family trees and diagrams will help you visualize the family connections and evaluate the shared DNA, like we've talked about in a previous chapter. This can help you see if there's missing information or conflicts and help you analyze everything. It also can help you explain your research when you are going to be creating a research report. So, it's useful for your own analysis and for sharing your conclusions. If there's no family tree associated with a critical DNA match, you might need to build their tree for them. Building the tree back 50 years before the time when the ancestor you're attempting to identify lived can be a good rule of thumb. And you can use public record databases, obituaries, newspapers, Google, vital record indexes, etc., to look for clues about a DNA match's parents or grandparents so that you can then construct their tree. Sometimes you just have to send them a message and ask them who their grandparents were to help you build their tree. Some tools available to help us build a tree, even if it's private or stumpy. We can look at the 23andMe Your Family Tree tool, Through Lines at Ancestry DNA, the Theory of Family Relativity at MyHeritage, the Genetic Affairs Auto Tree and Auto Pedigree, and the What Are the Odds tool. So let's go into each of these a little bit. 23andMe generates a tree solely on the amount of DNA. This shows your matches in kind of different branches of the tree based on the shared matching. And it's great because it takes into account not only how much DNA you share with them, but how much they share with each other. So that is based purely on DNA with no reliance on documentary data. So parts of the tree could be inaccurate, but it can also be useful for clues when you're trying to figure out who a DNA matches to see how 23andMe thinks they fit into the tree. You can edit the tree, but you can't share the tree with anyone. It's just for you. So this is just a helpful tool for separating your matches into meaningful groups and seeing where they might fit in. Through Lines at Ancestry DNA is a program that searches for people who appear in both the family tree that is connected to your DNA results and other ancestry member trees. And the feature creates a descendancy chart that shows suggested connections between you and your matches. The potential relationships between you and your matches are shown in the descendancy chart along with the amount of DNA you share. It's essential to verify these relationships, though, because the trees are sometimes inaccurate just because of the nature of a user submitted tree at Ancestry. So sometimes we just need to do additional analysis on through lines. Theory of family relativity at MyHeritage is very similar to through lines, and it shows a descendancy graphic that illustrates the generations from you to your common ancestor. And it uses the smart matches and shared ancestral surnames, and all of these clues are available to you at MyHeritage to help in identifying the connections between you and your matches. Genetic Affairs has an auto tree program which reconstructs family trees for family tree DNA profiles and identifies common ancestors among the matches. And they can directly gather the info from family tree DNA, which is great, and create an auto tree for the DNA matches that have a family tree in their account. Another tree building tool at Genetic Affairs is Auto Pedigree, and this uses auto tree predictions to offer multiple hypotheses about how a person can fit into a created auto tree, which can be vital in unknown parentage cases. So there's many tools out there to help and assist us. These different tree building tools are a logical starting point or sometimes a shortcut to figuring out who your DNA matches are and how you connect. Before there were these tools to help us and give us shortcuts, you had to look for common surnames in each of your DNA matches tree and build a connection between your tree and their tree. And it was a little more challenging. And sometimes that's still how we prefer to do things. It just depends on your project and what tools you want to use. So, after you use pedigree triangulation and documentary research to find common ancestors, the What Are the Odds tool is an advanced tool at DNA Painter that can help you work out where a DNA test taker may fit into the family tree. And it's often used for unknown parentage cases because you're looking at a bunch of genetic networks, but you're not sure where your adopted person fits into that genetic network. And you can use the amounts of shared DNA input into Watto to help you come up with some different probabilities and consider the most likely relationship scenarios. So, like any tool, Watto or What Are the Odds has different limitations and strengths. And one of the strengths is that you can enter the amount of shared DNA from various companies to help you figure out where a person fits within a known family tree. So you can enter amounts of shared DNA from GenMatch, 23andMe, MyHeritage, all different places. However, it doesn't work well for families with endogamy, pedigree collapse, or multiple relationships. And it doesn't work well for matches less than 30 to 40 centimorgans. So it also can't definitively tell you which person in the genetic network or known descendancy tree is the correct parent or grandparent, but it can give you probabilities, and then you have to reason and correlate that with documentary evidence to come to a conclusion.
We are very lucky now to have so many tools. It's amazing. Well, let me illustrate how I used pedigree triangulation with my Benjamin Cox case. In this case, I used Ancestry Throughlines as a tool. I had found so much indirect evidence pointing to Benjamin Cox as the father of my fourth great grandmother, Rachel Cox, but I wanted that additional proof of DNA. So, assuming Benjamin Cox was Rachel's father, his other children's descendants would likely be related in the range of fourth to eight cousins. And so I could have so many different relationships. Third cousins 3 times removed, fourth cousins twice removed, fifth cousins once removed, and so forth. And so I have a very large match list, like many of you listening at Ancestry, with thousands upon thousands of matches. And I knew that these matches would be sharing less DNA and be hidden in larger categories of relationships. And so I decided to add Benjamin Cox to my tree connected to my DNA test as a hypothesis to test. And then Ancestry's technology searched user-created trees to find DNA matches that also had a connection to Benjamin Cox. And Throughlines found 66 DNA matches that had Benjamin Cox in their family tree. And so then I started the work of checking the trees, and I looked at the parent-child relationships for each of the lines from these DNA matches back up to Benjamin Cox to see if they all genuinely intersected at Benjamin Cox as the most recent common ancestor. And I also have my tree on MyHeritage, and I was able to use the theory of family relativity to also explore there. And in this case, I searched through all the suggestions just by typing in Schultz. Rachel Cox married Hickman Monroe Schultz, and so I was able to find some more documentation there for trees and DNA matches. And so after all of the DNA, the trees, the documentary work, I concluded that Benjamin was the father of Rachel Cox. And I found that there were matches that descended from all of Benjamin Cox's children. There were several, and they shared DNA with me or other family members. I had recruited at least 4 other people who were descendants of Benjamin Cox, and they shared their DNA results with me on Ancestry, and I used their DNA matches as well. And 2 of them were a generation closer, and they had better matches than I did. But having this large body of evidence using DNA shared matching and the pedigree triangulation, I was able to prove that Benjamin was indeed the father of Rachel Cox.
Thanks for sharing how you did that. And it's useful to really understand how you can use through lines and pedigree triangulation to come to a conclusion. Well, next week we'll talk about segment triangulation using segment data and chromosome browsers in part 2 of this chapter, chapter 8, about DNA tools and methodology. So we will talk to you again next week.
All right, bye-bye, everyone.
Thank you for listening. We hope that something you heard today will help you make progress in your research. If you want to learn more, purchase our books, Research Like a Pro and Research Like a Pro with DNA on Amazon.com and other booksellers. You can also register for our online courses or study groups of the same names. Learn more at familylocket.com/services. To share your progress and ask questions, join our private Facebook group by sending us your book receipt or joining our courses. To get updates in your email inbox each Monday, subscribe to our newsletter at familylocket.com/newsletter. Please subscribe, rate, and review our podcast. We read each review and are so thankful for them. We hope you'll start now to research like a pro.